Hello, everyone, and welcome to Cognito Key. Today, we are going to get into something that is literally powering your life right now. The amazing little bit of tech that turns the electricity from your wall into power your gadgets can actually use. I'm so glad you're here, where we try to make all these complex ideas super simple and clear for you. So just think about it for a second. You plug your phone charger into the wall socket, and just like magic, your phone starts charging. But how? I mean, have you ever wondered what's really going on in there? Because the power in your wall is totally different from what your phone actually needs. And that right there brings us to the big challenge. It's this fundamental difference between AC and DC power. See, the electricity coming out of your wall is called alternating current, or AC. The best way to picture it is like a wave in the ocean, constantly moving back and forth, back and forth. But all our precious gadgets, our phones, our laptops, they can't handle that. They need direct current, or DC, which is a nice, steady, straight line of power. So the question is, how do we get from one to the other? Well, we do it with a really clever little circuit called a rectifier. Its only job in life is to take that wavy, unpredictable AC and transform it into a steady, one-way pulsating DC. Honestly, this is the unsung hero hiding inside pretty much every piece of electronics you own. Okay, so there are a couple of ways to build one of these rectifiers. Let's start with the most basic one, the Half Wave Rectifier. It's really simple, but as you're about to see, it's also pretty wasteful. The easiest way to think about it is to imagine a one-way gate. When that AC wave is flowing forward, that's called the positive half cycle, the gate just swings open and lets all the power through. But the moment that wave tries to flow backward, in its negative half cycle, bam, the gate just slams shut and blocks it completely. And right there, that's the big problem, isn't it? The half-wave rectifier literally just throws away half of the electricity it gets. It's kind of like ordering a whole pizza and then just throwing half of it in the bin before you even start. There has to be a better way, right? And of course there is. This is where the full-wave rectifier comes into the picture. It's the smart, efficient upgrade we were all hoping for. So instead of a simple gate that just blocks traffic, think of the full-wave rectifier as a really smart traffic management system. When the power is flowing forward, it directs it down one road. But, and this is the clever part, when the power tries to flow backwards, it doesn't block it. Oh no. It actually reroutes it, flips it around, and sends it down that very same forward path. And what's the result? Well, it means the entire AC wave gets used. The whole thing. Nothing is wasted. It takes both the forward and the backward parts of the wave and turns all of it into useful power. Okay, so we've got the simple but wasteful half wave versus the clever and efficient full wave. Let's put them head to head and just look at the hard numbers. Just take a look at this comparison. Okay, yeah, the half wave is simple, just one diode. But look at the ripple factor. That's basically a measure of how smooth and stable the power output is. Lower is better, and the full wave is just so much smoother. But the real story here, the number that changes everything, is the efficiency. 81.2%. That's the efficiency of a full wave rectifier. It's taking over 4/5 of that messy AC power and turning it into clean DC power. That is just fantastic. I mean, when you see it on a chart like this, the difference is it's staggering. It's not even a competition. The poor half wave is struggling down there at about 40% efficiency. The full wave is at 81.2%. It is literally twice as efficient. You get double the power for your money. That is a massive, massive difference. So you might be asking yourself, with a difference that huge, why would anyone on Earth still use a half-wave rectifier? And that's a perfectly logical question. Well, like with almost everything in engineering, it all comes down to trade-offs. It really just boils down to this. The half-wave rectifier is incredibly simple and very, very cheap to make, but it's also incredibly inefficient. The full wave, on the other hand, is super efficient, but it's a bit more complex and costs a little more to produce. And, this quote from one of our sources just sums it up perfectly. If what you need is the cheapest possible device and you really don't mind wasting a lot of power, then maybe the half-wave rent is for you. But for basically any modern application where performance and efficiency matter at all, the full wave is the undisputed champion. When you really think about it, this whole journey from half-wave to full wave is a story about human innovation, right? It's this constant push to be better, smarter, and more efficient. It really makes you wonder, as our world needs more power and less waste every single day, what's the next big breakthrough going to be?
I really hope this explainer helped you understand that fascinating little process that's happening inside your chargers all day, every day. If you found this useful, it would be absolutely amazing if you subscribe to Cognito Key for more deep dives just like this one.
And of course, please don't forget to hit that like button, it really helps us out, and share this explainer with anyone you know who just has a curious mind. Thank you so much for watching, and I'll see you in the next one.